Hello, let us sorry about that. Let us start 6.6. 6.6 deals with inverse trigonometric functions. So I'm going to present my screen. Here is the inverse trigonometric functions. See, here it is. The first one is sine x, sine inverse x. For sine inverse x, the domain is -1 to 1. X lies between -1 and 1, and the range is -π/2 to π/2, both including both. So the nature of sine inverse x is, that is, the actual definition is this: if y is equal to sine inverse x, then that implies and implied by x is equal to sine y. So that is the actual easy to understand way of speaking. So if y is equal to sine inverse x, then x is equal to sine y, but there is a restriction. X must be in between. In this case, x is in between -1 and +1, and y is in between -π/2 and +π/2. So that is the restriction. But when y is equal to sine inverse x, when you see an equation like y is equal to sine inverse x, you may replace that by x is equal to sine y. Same is the case of cos inverse x. When you see y is equal to cos inverse x, its domain is from -1 to 1, but the range is different. Range of cos inverse x is from 0 to pi. So same formula applies here also. If y is equal to cos inverse x, then x is equal to cos y. And then you have tan inverse x, but for tan inverse x, domain is -infinity to infinity, and the range is -π/2 to π/2. And then cot inverse x, that is -infinity to infinity, 0 to pi. Then secant inverse x, the domain and range, I'm skipping that part. And cosecant inverse x, that also I'm skipping the domain and range because they do not play very important role in calculus. Now the differentiation. We are going to differentiate sine inverse x. So we will come to this in a minute. So first we are going to differentiate sine inverse x. Okay, y is equal to sine inverse x, and therefore x is equal to sine y, or sine y is equal to x. Now you differentiate x with respect to y. Dx over dy is equal to cos y. That is, cos y is square root of 1 minus sine square y. That is the trigonometric identity. And 1 minus sine square y means 1 minus x square, because sine y is the same as x. So dx over dy is square root of 1 minus x square. Therefore, dy over dx is 1 over the reciprocal of 1 over 1 minus x square. So that is the derivative of sine inverse x. Now the second one is the cos inverse x. Y is equal to cos inverse x means x is equal to cos y. So dx over dy is negative sine y, because derivative of cos y with respect to y is negative sine y. That is negative square root of 1 minus cos square y. Cos y is x, so negative square root of 1 minus x square. Therefore, dy over dx is negative 1 over square root of 1 minus x square. Next is tan inverse x. So tan inverse x, y is equal to tan inverse x. Therefore, x is equal to tan y. So dx over dy is secant square y. Derivative of tan y is secant square y. And secant square y is 1 plus tan square y. That is a trig identity. And therefore, dx over dy is 1 plus y square. Tan y is x. Tan y is x, so it is 1 plus x square. And therefore, dy over dx is 1 over square root 1 over 1 plus x square. Cot inverse x, y is equal to cot inverse x. And so x is equal to cot y. Dx over dy is negative secant square y. So negative 1 plus cot square y in parenthesis. That is negative 1 plus x square. That is, so dy over dx is negative 1 over 1 plus x square. Next is secant inverse x. Secant inverse y is equal to secant inverse x. So x is equal to secant y. Dx over dy is secant y times tan y. And secant y times square root of secant square y minus 1. Secant square y minus 1 is tan y. X secant y is x. So this is right side is x times square root of x square minus 1. And so dy over dx is equal to 1 over x times square root of x square minus 1. The last one is y is equal to cosecant x. Y is equal to cosecant x. Therefore, x is equal to cosecant y. So dx over dy is the derivative of cosecant function is negative cosecant times cot. So it is negative cosecant y times cot y, because we are differentiating with respect to y. That is equal to negative cosecant y times square root of cosecant square y minus 1. That is equal to negative x times square root of x square minus 1. And that is dy over dx is the reciprocal of that, negative 1 over x times square root of x square minus 1. Okay, now, so this is how you find these formulas. Those formulas are written at the top. So these formulas are written at the top. Sine inverse x, derivative is 1 over square root of 1 minus x square. Cos inverse x, derivative of that is negative 1 over square root of 1 minus x square. Tan inverse x, 1 over 1 plus x square. Cot inverse x, negative 1 over 1 plus x square. Secant inverse x, 1 over x times square root of x square minus 1. Cosecant inverse x, negative 1 over x times square root of 1 plus, square root of x square minus 1. And the antiderivative. So derivative of sine inverse x is 1 over square root of 1 minus x square. So antiderivative of 1 over square root of 1 minus x square is sine inverse x plus c. Antiderivative of negative 1 over square root of 1 minus x square is cos inverse x plus c. Antiderivative of 1 over 1 plus x square is tan inverse x plus c. Antiderivative of negative 1 over 1 plus x square is cot inverse x plus c. Then antiderivative of 1 over x times square root of x square minus 1 is secant inverse x. And finally, the and the derivative of negative 1 over x times square root of x square minus 1 is equal to cos inverse x. And then we have discussed those formulas. Now the remaining are the questions from the book. So we will work out this problem. Evaluate integral 1 over square root of a square minus x square. Whenever you see an a square minus x square under radical sign, the substitution is x is equal to a cos theta. X is equal to a cos theta. So dx is equal to, x is equal to a sin theta. I repeat, when you see square root of a square minus x square under radical sign, substitution must be x is equal to a sin theta. So dx is equal to a cos theta d theta. So a square minus x square, here you have an a square minus x square, that is a square minus a square sin square theta, that is pull out a square times 1 minus sin square theta, that is a square cos square theta, because 1 minus sin square theta is cos square theta. So this becomes 1 over square root of a square minus x square is 1 over square root of a square cos square theta, and dx is a cos theta d theta, and the denominator is the square root of a square cos square theta, that is a cos theta. A cos theta cancels, so it becomes integral d theta. Integral d theta is theta, and theta plus c. Now what is theta? Theta is, you divide this, x is a sin theta, so sin theta is x over a, therefore theta is sin inverse x over a. So sin inverse x over a plus c, that is the antiderivative of 1 over square root of a square minus x square. So here ends the first part of 2.6. I will be posting these notes part by part, because there is some technical issue regarding my video posting. So I'll be posting this section, but I mean part by part. So here ends the part 1.